For quality family television you've got to see, there's only one choice, WAX-TV 34 Henderson. Chances are you or someone you know is living near the proposed hazardous waste incinerator site in Granville County. Join us for a WAX-TV 34 special presentation, Granville County, Potential Wasteland, to be broadcast at 8 p.m. Thursday and Friday at 12 noon. Dr. Paul Connett, chemistry professor at St. Lawrence University, spoke in Oxford recently on what he sees as the dangers of incineration. Plan to see Granville County, Potential Wasteland here on WAX-TV 34.
I'm going to introduce each of tonight's speakers in the order in which they'll speak. After they speak, the next speaker will just get up and proceed in that order. To my right is Dr. Paul Connett. He received his first degree at Cambridge University, second PhD in chemistry at Dartmouth. He's an associate professor of chemistry at St. Lawrence University in Canton, New York. He's a national coordinator for the work on Waste, I'm reading his writing. Waste USA. He's a member of the advisory panel of Office of Technical Assessment, and a member of the advisory panel of New York State Senate. He's made 550 presentations in 40 states. He has now 18 videotapes. He has a weekly newsletter on waste and 4 papers on dioxin. He will be speaking first. Next, he'll be followed to my immediate left by a gentleman that needs no introduction at all. He's chairman of our site review committee, John Pye, followed by Mr. Matt Petrovic, another member of our site review committee, and following Mr. Petrovic will be Chris Cummins, vice president of our organization, Granville Residents Opposed to Waste. So without further ado, I give it to Dr. Cummins.
I'm looking at this magic number here, 11, and I just want to say that I've had the pleasure of meeting 3 heroes since I've been here in North Carolina. One was Dr. Mark Garrett in Caldwell County. Another one was Dr. Roy Gorman. And sitting in the front there, Dave Bolek from Channel 11. I think all 3 would agree with me that it is partly a reflection on our times and partly a reflection on the state that you can become a hero simply by doing your job honestly and sincerely. That's what Mark Garrett did as a doctor, that's what Roy Gorman did as a state environmentalist, and that's what Dave Bolek did as a professional journalist. They did their job. Now, I'm going to be talking about 3 scandals in North Carolina. One is the scandal that you know about, the 10 years of abuse in Caldwell Systems, which was allowed to continue despite the human devastation that caused, and the cover-up by the state. That was one scandal. Another scandal is that a facility which threatens to copy that is Carolina Solite, which is an aggregate company which is burning hazardous waste right now in Stanley County. And the third scandal, I'm sure you're very familiar with, is the proposal to put an incinerator, regional hazardous waste incinerator, using the full powers of the state, eminent domain, to rip away a chunk of land that's been in the possession of families for many, many years, give it over to a private corporation to run for profit, and a private corporation, its own parent company is German, which has a terrible track record in Germany, which has included a 5 million Deutschmark bribery scandal and 2 suicides. That's the third scandal. But before I get into the scandals, I would like to talk about waste management, hazardous waste management. I'd like to get into what you always contend with. The ultimate argument that you all have to face is once you've proved that this is a bad idea, then the last obstacle that you have to cross is to prove that there is a better alternative. And so I'm going to begin with that better alternative. And to a large extent, it doesn't differ a great deal from what the state talks about. The difference is, I mean it, and they don't. And if you wanted to clearly show that they don't mean what they say, you only have to look at where the money goes. They talk very, very loudly about waste reduction. They talk very, very proudly about their waste reduction program. And yet they're spending less than $500,000 on that at the same time that they're embarking upon a $70 million project in this facility here. So number one, of course, is waste reduction. That is essentially shifting the problem from the back end to the front end. It's essentially saying to the chemical industry, if you are clever enough to make these compounds, you must be clever enough to dismantle these compounds safely. If you can't do that, then you shouldn't make them in the first place. We want you to shift some of your creativity from production to maintenance to make sure that your production does not damage us and the environment. That involves modification of processes, it involves substitution of non-toxics, it involves in-house recycling. And the very, very good news is that where progressive companies take that as their number one priority, they save money. 3M Corporation, 1,900 projects aimed at waste reduction in their factory, saved themselves $292 million. Waste is the visible face of inefficiency. If you make less waste, you're less efficient and you make more money. So that's number one. Number two, waste exchange. If you cannot stop that waste leaving your gates, at least the first thing you should do is to see if another company can use it as a starting material. That needs more information than it does technology. It means communication. Getting this in computerized bulletins to every company to know what's out there before it is thrown away. Thirdly, waste recycling. This is particularly important for solvents. One of the things is that when you use a solvent, you do not destroy it chemically. You make it dirty. And it makes eminent sense to filter that solvent and or redistill it. But in some way get that solvent back. That just makes enormous sense. Right now, whole tank loads of solvents are going into incinerators and are damaging and threatening the environment. Fourthly, after you've done those three, reduction, waste exchange, recycling, chemical or biological treatment, for two particular areas of concern. You cannot destroy metals. You cannot destroy metals in incinerators no matter how high the temperature, no matter how long you burn the waste. That you learn in the first lesson in chemistry. And I can only conclude that some state officials have never had their first lesson in chemistry. So one is to remove the metals and use those again. Secondly, the other element of particular concern is chlorine. Remove the chlorine. You cannot destroy chlorine. When you burn materials containing chlorine, you produce small quantities of even more toxic materials than you started with, and I'll elaborate on that in a moment. After you've done that, and only after you've done that, can you consider the possibility of incineration. But incineration of materials which do not contain metals and do not contain chlorine. Personally, I favor if you're going to have any incineration at all, I favor on-site incineration. Why? Because those companies, particularly the chemical companies, have more expertise, have more equipment, have more analytical ability, and know more about those chemicals than anybody else. They are the ones who are most likely to do it safely. Compare that with the task of importing waste, very poorly defined, more often than not, from all parts of the country, probably all parts of the world, with this German corporation. And you realize that there's a world of difference between those two strategies. Currently, there are about a dozen incinerators, commercial incinerators in the country, and it's a nightmare wherever they're sited. But there are about 200 on-site incinerators, which are creating far less concern. After that, all these things now have been done essentially on-site. After that, what do you do with the stuff that's left over? Some of the people in Aradol have come up with a very interesting notion. Their notion is that of containerization, special containers. And those special containers will take the rest. But what you say to the companies are, look, we will give you tax incentives to do it right. Reduction, exchange, recycling, chemical treatment. For that, we'll give you incentives for research, for development, for capital equipment. That which is left over has to go into these containers. And guess what? You do not lose ownership of the material that you put into those containers. You retain liability, you retain ownership. You can store them on site for so many years, then you move them over here, then you move them over here. After a certain amount of time, they come back to square one. In those containers will be a computerized list of all the chemicals. So at any time, the company can choose the option of dealing with them in another way. Always have that option. So what I'm essentially saying is we're looking at two methods of recycling. One is what I would call productive recycling, where you do the right thing right away, save yourself money, protect the environment. Secondly, you have this containerization, which I would call unproductive recycling. You don't get rid of it, it keeps coming back to you, it's expensive. And until you do the right thing, you don't get rid of it. I believe that strategy will drive the right solutions, as opposed to incineration, which drives the wrong solution. Now, one of the crocodile tears that the governor cries in this state, along with all those others, oh, they believe in waste reduction. I think it was Elvis Turner who said, we are aggressive about recycling, and it's hard to imagine being aggressive about anything. Linda Little is aggressive about recycling. And there they peddle one of the great myths. One of the great myths is we have 90% of our waste being handled on site. And you purists are trying to make all this fuss about the other 10%. Surely we can have our little incinerator if we're doing all these good things up front. What are you complaining about? Well, what the big myth is that 90% that's handled on site is mainly water. What we're looking at is wastewater treatment, is the largest tonnage of material that's being handled on site. So what they're doing is removing a relatively small amount of toxic material from their water effluent, which is a good thing. I'm not opposing that. But what you should only count in waste reduction is the amount of waste material they filter out, the sludge, and not the total amount of water that goes along with it. When you do that calculation, then you're looking at a very sloppy operation. Not just 10%, but there are massive quantities of material which should be reused, exchanged, and recycled, which are going to incinerators and landfills elsewhere in the country. Okay, now I'd like to just run through 6 basic problems with hazardous waste incineration. Some of them are theoretical, some are practical. The first one I've alluded to already. Some things cannot be destroyed in incinerators. Metals. And it turns out that as far as metals are concerned, the worst thing that you can do with many things is to burn them. And there's some ironies here. The better The combustion, the higher the temperature that you burn, the more gases, more of these metals that get into the gaseous phase and out of the stack. The higher the combustion efficiency, the more of chromium-3, which is converted to chromium-6. Chromium-3 and chromium-6 probably means nothing to most people in this room. But there are two forms of chromium. One is relatively non-toxic, the other one, and non-carcinogenic, non-cancer causing, that's chromium-3. Chromium-6, on the other hand, is extremely toxic and cancer causing. So if you convert the chromium-3 to chromium-6, then that would be bad. And so the better you get at burning some of the organics, the worse you get with chromium. The other thing is that the more chlorine that you have in the waste stream, the more metals that get into the vapor phase, because the chlorides of metals are more volatile than the oxides. And the more chlorine that you have in the waste stream, the more chromium-3 that's converted to chromium-6. And therefore, the more that gets out of the stack is volatile. And so, there are very, very basic flaws with some fundamental chemistry of incineration, even under ideal circumstances. The second issue is that some things, when you burn them, produce more toxic byproducts than you start with. And that applies to anything containing chlorine. And when you burn anything containing chlorine, the chlorine doesn't disappear. A lot of the chlorine will end up as hydrochloric acid, and that's mainly what caused a lot of the damage to vegetation in coal systems. But the chlorine also ends up combined with carbon in a variety of ways to form things like chloroform, phosgene, chlorinated benzenes, chlorinated phenols, and two families of compounds which strike terror in the heart of most chemists, and that is dioxins and furans, the most toxic materials that we've ever been able to make in the laboratory. So you may be getting rid of large quantities of toxic material, but the exchange is you get a very small quantity of even more toxic material. You would think that people would do a balancing act. You know, which is worse, the small quantity, the micrograms of this, or the tons of this? Is it a good deal? The reason people don't do that calculation very often is that those tons of material come from somewhere else. They have got rid of it, and it's only the community only gets this byproduct at the end of the day. The third issue is how well these plants are regulated, monitored, and enforced. And here you've got a 10-year sick joke on that issue. The Cold systems was incredibly poorly regulated, pathetically monitored. Those who did try to monitor it had their jobs removed from them. I'm talking about Dr. Roy Gorman, who lost his lab, his greenhouse, and his department, and was put behind a desk job, and he was sent for psychiatric treatment. And yes, we are talking about Raleigh, North Carolina, not Moscow, Soviet Union. It's sick. There are three things that you need to protect public health: strong regulations, adequate